Okay, so first we'll be solving for strontium phosphide, which is written like this. So first, what we need to do is we need to look on our periodic table, and we'll see that phosphorus has 5 valence electrons. So we'll write the 2 phosphorus up here with 5 dots in this order. And as you can see, these two have lone pairs. Contain 5 valence electrons. For strontium, you can see it's in the second column, so it contains 2 valence electrons. So we'll write it like this. Okay, so now to assemble the equation, we need each valence electron from strontium to be paired up to the 2 phosphorus. So this is how we'll write it. So first, we'll arrange them in this order. We'll put strontium, and then phosphorus, strontium, phosphorus, and then strontium again. Then, we'll put, since we're transferring the 2 valence electrons from each strontium, we'll fill up all 8 dots on phosphorus. And this works because it's transferring electrons, and it's still technically connected to each strontium, meaning they still have access to their 2 electrons, and phosphorus has access to 8 electrons. So to guard the valence electrons, we'll put brackets around each phosphorus and put their charge, which in this case, if you look on the periodic table, phosphorus has 5 valence electrons, but it wants to have 8. So it wants to steal 3 valence electrons. So it'll have a charge of -3. So it would put 3 minus. And strontium wants to give away 2 valence electrons, so it'd have a charge of +2. So we'll write it like this. And that's our equation for strontium phosphide. Okay, so next we'll be solving for the ionic Lewis structure of magnesium chloride, which is written like this. So as you can see, chloride actually has 2 atoms compared to magnesium has 1. If we look on the periodic table, we can find their valence electrons. So as we can see, chlorine, which is also known as chloride, is in column 7, meaning it has 7 valence electrons. So we'll draw that here. Chlorine, and we'll draw 7 dots on each one. And then, as you can see, magnesium is in the second column, which is an alkaline earth metal, meaning it only has 2 valence electrons, which are these dots here. Okay, so now let's redraw it. So first, we need to make sure that chlorine is not touching chlorine, so we'll draw it like this. And then we need to make sure that each chlorine has 8 dots, and magnesium has 0. So this is how we'll do it. So let's redraw it here. So we need to make sure that chlorine has access to 8 dots. So we'll transfer this over here and this over here. So basically, this is the final equation for it. The chlorine and magnesium and chlorine. We draw all 8 dots because we just transferred them over to chlorine. And we put brackets around them to protect it. And we put the charge. Since chlorine is on the 7th column, it wants to have 8, so it's going to steal 1 electron. So we don't write it because it's only -1. Magnesium, on the other hand, has a charge of +2 because it wants to give away 2 electrons so it can have 0. So we'll put 2+. That's your final answer for magnesium chloride.